Hello and welcome to Algebra. Today we're going to be looking at going back and forth between rational form and radical form with rational exponents going back and forth between the two. Okay, so a couple things we need to understand about rationals, exponents and the radicals themselves. We have rational exponent form and we also have radical form, so those two. Now, when you have the rational exponent, you have the fraction, rational meaning fraction, basically, and the radical is this little squirrely looking thing here, okay? The radical is this symbol. So, radical form, I don't know if you've ever seen skateboarding, but you might think of the sort of the awkward position that the skateboarders get in as radical. Of course, skateboarders, sort of West Coast kind of thing, totally radical, all right? Take a look at this clip. So you can see sort of that radical form. You can just kind of visualize that skateboarder in that position for the radical form. Now, you can transform back and forth between both of these, between rational exponent form and radical form. And of course, from that clip, you can see transformers going back and forth. So the stupid version, inside, outside, and that'll make a little bit more sense when we get into this. Now we're going to go one direction this time. We're going to be doing from the rational exponential form into radical form. So let's look at this example. If we just have these bases, P and R, these variable bases, remember the P and the R are the bases, and these are the exponents. These are rational or fractional exponents, and we want to transfer this into radical form. Remember the skateboarding video, it's going to look like this. And if there's no number here, it's going to be understood to be a 2. If there is a number, of course, there's something else there. But the default setting for that is 2 if there's no number visible. And this tells you where this stops, where to cut off, and where you can start something else. So look for that little tail there. Alright, now we want to think about this. The stupid version is inside, outside. And actually that's not 100% true because there are two versions of this, but I'll show you the inside-outside first. Alright, so we're going to set up both of these. Will have its own little radical. Now, sometimes when the radicals are the same, you can combine them, but of course in this case they cannot be combined, and I'll show you why in just a moment. Now I'm going to put the P in the radicand and the R in the radicand, that is inside the radical. And this top goes inside and this one goes outside. Inside, outside. Now these numbers here, the denominators in the rational exponent form, if those are the same, you can actually combine these in the same radicand, but you cannot do that here. So I'm going to go ahead and say that this is complete, and that is in the proper form. Now just so you know I do the stupid version, the inside-outside. You may not like that. There is another possible way to write that, and that would be the cube root of P. Of course, this would be the 5th root of R to the 4th. This is the 3rd root or cube root of P squared. You can also write it this way. And so this is also a potential answer. But I'm just going to stick with the inside-outside. So understand, for any of these that you're going to write, you can also put this in parentheses and stick that 2 outside. But in the sort of the stupid version, just the scaffolding to help you remember what's going on, we'll use inside-outside. Okay, now let's look at a slightly different version here. Now, the 25 to the 1/3, from what we've looked at earlier, if there is an integral base, an integer that is a base, then I'm going to split this up and look. There are 2 5s. For every 3 I see, I pick 1. Now, I don't even see 3. There are, these are obviously prime numbers, 5. No other factors will go into it besides 1 in itself. So this is as far as it will break down. I can't make this into an integer. This is going to be an irrational number because it doesn't go cleanly, if you will. So that doesn't work. So I'm going to have to leave it in, now it says radical form. If I could see 3 bases, like if there were 3 5s there, like if this were 125, then I could go ahead and this would be just the number 5, but there weren't enough bases for that to happen. So this is not going to be an integer, this will be an irrational number, meaning decimal goes on forever, no repetition at all. Alright, so 25 to the 1/3. Remember, inside, outside. Again, there's a different way you can put that, but we're just going to leave it that way. We're going to put the radical symbol, 25 in the radicand, inside, outside. This part I'm going to distribute. Look at the Chuck Norris video on that one. So x squared, this is a Xerox, so times 1/2. This is a 1. 1 times 1/2. So this one's already in radical form. This is not yet. So this is x to the 1st power. This is y to the 1/2 power. (25) to the 1st power is just 25. So this is the cube root, the 3rd root of 25. Now x to the 1st, I don't really have to say to the 1st. I can just say x. And this I do need to put into radical form. Now, a little tip, the standard protocol is to put, I don't know how to say it, but something that's not in radical form. It's just a regular exponent, it's just an integer, some rational number. Then you're going to put that out front, just to arrange it that way. So x times the cube root of 25, and then times, we're going to put this in radical form. So, of course, y goes in the radicand, inside, outside. Now, here's the thing. Square roots, you don't necessarily have to put the 2. It's optional, but that's not the standard way to put it. And the 1, of course, I don't need to put. So, I'm going to do x times the cube root of 25 times the square root of y. And the reason I don't have to put any number here is because it's just understood that's a 2. Just like it's understood that y to the 1st power is y. And that's going to be my answer. That's it. Thank you very much for watching Algebra.